Alright, I am starting a e-bike battery build. I am converting my mountain bike to an e-bike, and I am doing a 36 volt 500 watt conversion, so I need a 36 volt battery. The other thing to consider is that my mountain bike is full suspension on the rear, so I can't really put the battery in the A-frame of the bicycle, so I will have to hang this out the back off a bicycle rack. But full suspension bikes are hard to put a bicycle rack on, so my options are pretty limited. But I have managed to find a smaller bicycle rack on the back of the for the back of the bicycle that sort of hangs off the seat post, and I've taken some measurements, and this battery should fit. So what do we have here? So anyways, since I'm doing a 36 volt battery, that means I have to do a 10S lithium ion configuration, 10S. Since the median voltage of a lithium battery is 3.7 volts times 10, that'll give me 37 volts, which will work fine for a 36 volt e-bike. So I have to do 10 cells in parallel. So then the next question you have to decide is, well, how many are you going to put in sorry, that's 10 in series. So then the next question is, how many are you going to put in parallel? Well, I am going to put 6 in parallel, as you can see here. 6 in parallel, 10 in series. Should be about a 15 amp hour battery at 36 volts. A little under 700 watts. Should be fine for the bike that I'm, should be fine for what I'm trying to do here. So anyway, so one other thing when you're building e-bike batteries is this isn't the same as a Powerwall. These batteries are going to be they're going to be used hard and quickly. They are going to be in a high discharge environment, so you cannot just use those modem cells, that battery hookup or battery clearance cells. Those batteries don't even like to push 1 amp. I mean, some of them have like a discharge rating of 0.5 amps, which is fine for a Powerwall, but not for an e-bike. These LGs that I got from battery clearance, these are 10 amp capable. And these actually came out of those like Lime scooters that are all over San Francisco and that. These actually came out of those scooters. So these are designed for, transportation and high discharge type settings. So here are the batteries. There are 60 of them, obviously. It's a 6P 10S design. I'm putting 6 in a group here, another 6, another 6, another 6, another 6. So there's 5, 6 groups here, and then another 5, 6 groups here. This will be the cover. Well, this will be the top. And there we go. I am going to solder this pack. I do have a spot welder coming, but I'm used to soldering, so I am going to solder the pack. I've started to design my bus bars. If I make this the main positive, since that's the positive, I'll drop in a bus bar here and solder fuse wires over to this main bar here. Which means that underneath I need to then put that bus bar here, which will come up, and then this bus bar will need to connect these packs here. I need to put one joining these packs here. I'll make sure I get this correct. Yes, joins those there. Alright, I have laid out roughly where my bus bars are going to be. The hot glue just temporarily holding them in place. I've thrown a couple zip ties through the pack on these bus bars here and here. That will keep the pack clamped, and it also holds these outside bus bars in place. What's going to happen is this over here will become my main positive, you can see, and this over here will become my main negative, because the pack sort of runs down, around, and around, and around, and out. So this is your main negative, this is your main positive. These are not touching in the middle here. Just in case anyone asks, they are not shorted to each other. They that's where they ended, and are I just used some hot glue to hold the back of them there, but they are not anywhere near touching each other, so that'll be fine. I am going to fuse weld each battery onto the bus bar, and then you know, once this whole pack's connected, then I'll slap a BMS on the side, and then I am going to actually heat shrink this pack, give it some extra protection when riding. And I may throw in a couple extra zip ties on the pack. I'll just see how it goes. But for now, this will be the basic layout, and I'll give you an update once it's all soldered together. So if my time-lapse camera worked, you just saw me solder the first side of this battery. I solder most of my batteries. I do have a spot welder on order. We'll start playing with spot welding, but I like soldering. I use fuse wires on all the batteries, a little blob of solder, and the hardest part when you're doing this is actually the solder on the bus bars. The copper bus bars love to suck the heat out of your solder, and you end up with these cold, very peaky solder joints if your iron is not hot enough. If you see cold, peaky solder blobs, those are actually not good electrical connections, and you'll find if you flicker with your fingernail, you'll be able to break the solder free from the bus bar, which means you do not have a good electrical connection. So, but all of these flowed nicely. All of these are rock solid. I don't have any peaky solder, so I think I will continue on the other side, and this battery is coming together. Okay, we finished assembling the pack. Every battery is fused onto the bus bars. Here's the main power positive, here's the main power negative. I will get a BMS and attach it on the side and put balance wires on the 10 sections. But let's just check our voltage here. Can you see the meter? Yes, you can. 41.3 volts, which is perfect. Fully charged, this will be 42 volts. And fully discharged, it'll go down to about 30 volts. But yeah, that should work perfectly for a 36 volt e-bike. And so next step is to get our BMS, attach that with all the balance wires. And then I am going to shrink wrap this. I'm also going to put a little insulation cardboard and then shrink wrap the pack, and then we'll start actually doing the e-bike install, and I'll do a video on that too.